Assalamu alaikum. Today, our topic of discussion will be building services. So, first of all, what is a building service? This is just like that if you imagine yourself in the most beautiful building in the world, but at the same time, there is no lighting, no heating, no ventilation. For the vertical transportation within that building, there are no lifts, escalators, uh, you're not getting any water supply over there, you're not getting any power supply, there is no security or firefighting systems, etc. And you are left in that building which is dark and cold. So that building will become an uninhabitable shell for you. So everything inside a building which makes it comfortable and safe for you, that thing comes under the title of building services. So initially when the human beings started to construct buildings, the prime objective was to provide shelter. But nowadays in this era of technology, a building must do what it was designed to do rather than just providing a shelter for yourself, because building provides us an environment where we can live, we can work, we can strive, and we can achieve more things. So, what does a building service include? Building services are, what makes a building come to life. They include energy supply, like gas, electricity, and renewable sources. It's heating and air conditioning. It's water supply, drainage, plumbing, etc. It's about the natural and artificial lighting. It's about how the building facades look. It's about the vertical transportations like escalators, lifts, staircases. It's ventilation and refrigeration, communication lines, telephones, and IT networks. It's about the security and alarm systems and fire detection and protection. So let's first start with the mechanical and electrical systems in a building. So a building must be designed with features to provide these following mechanical and electrical systems. First of all is better lighting, then comfortable space temperature. It should have good air quality and humidity present in that environment. There should be convenient power systems and communication systems. The sanitation system provided in that building should be of high quality, and there should be reliable systems for the protection of the users who will be using that building and the property itself. All these desirable features now have become a reality, whereas we are advancing in building mechanical and electrical systems. Okay, now let's talk about a practical example that you see, if we are having a block type building which does not have windows, just like departmental stores, these kind of buildings are totally dependent on electrical lighting and electrical ventilation and space conditioning. If it's a hot region, we would be needing ACs to make the space cool. If it's a cold region, we would be needing heating systems to make the space warm. And then if you talk about the high-rise buildings, high-rise building are a total flop if we do not have a high-speed vertical transportation, because it would not be easy for the users to use the staircase from ground floor till 105th floor or 200th floor maybe. So this is very important. And then comes the availability of water supply till the last 100th floor of the building. So if there is not high pressure water for drinking and cleaning purposes, and if there is not sufficient water for the protection against the fire in that building, that high-rise building is going to be a flop. So these mechanical and electrical systems in a building have an impact on the buildings in which they are installed. Number one is that they demand a considerable amount of floor and ceiling space, so that we have to allocate a proper space when we are at the preliminary stages of planning that building. These systems also add to the total construction cost of a building because especially sophisticated buildings such as research buildings and hospitals or computer centers, they have an elaborated system of mechanical and electrical equipment. These systems also increase in the energy consumption. Energy consumed by the occupied buildings, including residential or commercial and institutional and industrial facilities, they account for 50% of all the energy that is used by an industrialized country. And it also accounts for a large portion of the operating costs of such buildings. Now, the complexity of mechanical and electrical systems varies according to the living standards of the society, the climatic conditions of that region where the building is to be constructed, and what is the occupancy and what is the quality of the building. We have classification of mechanical and engineering system. Under mechanical systems, we have to install HVAC systems. HVAC is heating, ventilation, and air conditioning. And where we are not installing HVAC systems, like in hot areas, we can provide a similar system called ACMV, in which we give air conditioning and we do ventilation by mechanical means. Then comes the site utilities. Site utilities include water supply, drainage, sanitary disposal, gas supply, etc. Then comes plumbing. In plumbing, we have to see how the water will be distributed within the building, whether that water need treatment facility or not, and where in the building we have to provide the sanitary facilities. And very important one, especially for the high-rise buildings or multi-story building, is the fire protection. For fire protection, we again have to make sure that we have a separate fire water storage tank. There should be a sufficient water supply, standby fire and smoke detectors should be installed within that building, and fire alarms that can immediately send the notifications to the required personnels. Whereas in electrical systems, it comes the power, electrical power. There should to be a regular power, normal one. Then we have to have a standby and emergency power supply and distribution. So for a standby and emergency power supply systems, we must to have some kind of generators. In our houses, we have UPS as the standby or emergency power supply. Other than that, lighting, how we are going to light the building, whether interiorly or exteriorly, and if there is no lighting, what are the emergency lighting systems that are available to the building. Auxiliary systems include telephone, audio video, sound, security systems, and network connections, etc. Then we have building operation systems. The first one is transportation, that include elevators, escalators, even we have moving walkways or travelators. I hope you guys know what a moving walkway or travelator is. Escalators are actually stepped staircase which actually transports from one floor to another. It gives us a vertical transportation, whereas a moving walkway or a travelator does not have a step. It's just like a conveyor belt, and it's used in building projects where we have to cover a horizontal distance, a lot of horizontal distance. They are mostly present in airports because there are a number of gates that we design within an airport building where the aircraft would come and park for picking up the passengers. And you know how big the airplane is. So obviously it's not easy for people to travel from one gate to another just by themselves on their foot. So we provide travelators there. They keep on travelators keep on moving at a certain speed. People hop on to that, and without walking and without being tired, they move from one gate to another. Then another building operation system, processing, which includes products and food services, etc. Like if there is a restaurant in an airport or maybe a cafe in the hospital, so how would that work? What will be the food services? How would be the horizontal transportation of the food cargo from one place to another without being open to the customers actually? So that's what it includes. Then we have automation. That includes that how are we going to control the overall environment of the building and how are we going to manage it. So here is that how the checklist for mechanical and electrical systems for a building is useful for us. So if we have a comprehensive checklist that actually serves to determine that what is the building scope, what is the operational requirement of the building. This will actually be valuable in formulating the architectural concept and the building configuration and how the space will be programmed. How will it work actually? Early identification of these requirements will aid in evaluating the construction cost as well as allocation of space for M&E equipment, whether is it going to be placed within the interior of the building or the exterior of the building or both, etc., etc. Just like that, you can take example of our own building campus that we have to, because it's so hot in this region, that we have to provide the AC in our classrooms to maintain the temperature within a class. So we have installed split ACs, and split ACs have two units, inner and outer. Inner is mounted in the interior wall of your classroom, and the outer has to be placed somewhere outside the building. So if we have already evaluated that what will be the mechanical and electrical environment of the building, this would have not been the case. We could have gone for a centrally air conditioned classes and studio, and then we could have provided a separate electrical or mechanical room. The ideal thing is that whenever we start to design a building, we must consider and identify that what kind of mechanical and electrical requirements will be needed for our particular type of building. Now the thing is that not all the buildings require all of these services. So we should make a list first, which should be based upon the needs of that specific project. Mechanical systems requirements. So first come HVAC and ACMV systems. In mechanical system, we must have energy source, electrical power, gas. We should know about the energy source. What is available to us? Is it electrical power? Can we have energy from the gas or coal or oil or central steam, central hot water, chilled water, etc., etc.? What is the location of that energy source, and what is the capacity of the energy source which can aid our building? And then heating and cooling, that what type of central air handling equipment will be used, etc. Then comfort controls, what are the number of control zones within a building? Control zones are basically a room on a service floor or maybe a small room on the regular floor itself, which has all the connections and from where we can control the temperature and atmosphere of the entire building. Where is going to be the central plant located for that building? What is the capacity of that central plant? What is the normal capacity and what is the standby capacity? Then location of equipment, obviously central equipment rooms on floors, on roof. Then what is the location of the equipment? Will we be providing these central equipment rooms like on each floor, or are we going to provide a special service floor for that, or are we going to place it on the ground or maybe make a space on the roof too? What is the ventilation requirements? What is the air requirements outside? Is it minimum, high, 100%? What is the general exhaust conditions within a building. If we are preparing food in that, how the fumes and how the smoke of that food is going to exhaust. If it's an industrial area, what are the toxic and special exhaust systems? So we have to consider all of these. Next comes the plumbing and sanitation system. So again, we have to see that to run that plumbing and sanitation system, where the energy source will come from, whether it will be electrical power, gas, oil, or central steam, etc. Where the water supply will be from, whether it will be from public water, river, well, etc., and what will be the pressure of that water, at how much capacity it would be available, what is the location, and if we have to provide the hot water supply, where are we going to install and what kind of hot water heaters we will be installing in that building. What will be the case for the sewage disposal? Where will be the sanitary sewers or sewage treatment plants and septic tanks, etc., be placed? Where is going to be the drainage and filtering fields? Then we have to consider that how are we going to manage the storm or rainwater drainage. So first of all, we have to see that what is the local climatic conditions. According to that, what would be the kind of roof, and how much area is it going to affect, and if we are providing the means of discharge, where would be the locations. And then building facilities like plumbing fixtures and water and waste and soil piping, etc. Under fire protection systems, again, we have to see what is the energy source, where is the water supply from, what is the flow rate, because the pressure, because for fire protection system the pressure of water is very important, and location also, because, and we will decide whether we will be giving a separate service for the fire protection system, or are we going to combine it with the normal plumbing water supply within that building. Then how will we be storing the water for the fire protection system? Are we going to use some lake or pond nearby, or are we going to install some storage tanks? And for all of these three water storage possibilities, we have to see that where is the location and what is the capacity of these water storage. If we are installing the fire and smoke detection, we also have to see if we can install the thermal and smoke detectors. And we also have to make sure that we make stair pressurization. So what is stair pressurization? That in the stair halls we inject clean air, and we make sure that the pressure of that clean air within that stair hall is far greater than the other spaces within that building. And then we provide these stair halls with fire doors. So what happens is that when there is fire in the building, the pressure of air is reduced in the fire area, and because the pressure in the stair hall is greater, that way it is not going to allow the fire to move to the stairway, to the stair hall. That is what we call stair pressurization, and this is also the process through which we make sure that the occupants are not injured, because everybody is going to rush towards the exit and towards the staircases to exit the building. So while they are exiting that building, that greater air pressure will prevent the fire to enter into the stair hall, so that the occupants can easily and safely exit the building. Okay, so next we have to see what kind of fire annunciation programs that we can install, whether it's going to be a fire alarm or public address or fire dependent connections that we have to install there. What kind of fire extinguishing equipments are we going to install, whether portable extinguishers or automatic sprinklers. Then if we have to take help of the firefighting systems, where will be the fire hose and standpipe systems installed. Then we have to see the lightning protection, Lightning protection is especially important when it comes to air terminals or grounding conductors or quite high-rise buildings. Electrical system requirements. So first of all is the power system. We have to see that what is the normal energy source. Is it the utility power or on-site power? What is the location of it? What is the capacity? What are the power characteristics? How many phases does that have? What is the voltage that it is giving us? Where will be the service entrance? What will be the service requirements? Are we going to provide substations for a particular building, or are we just going to place a transformer walls near that building? What will be the emergency power source? Are we going to provide standby on-site generators, or are we going to provide a separate utility service for that? If we are going to provide the on-site generators, what will be the location of those generators and what will be the capacity? Then within the building, what will be the interior power distribution? What will be the primary voltages and what will be the secondary voltages? Where would be the distribution panel installed, etc., etc. And then on-floor distribution, that will each floor have box? Will there be underfloor ducts, or are we going to install integrated cellular floors or raised floors? What type of ceiling cavity conduit network we will be installing? So we have to consider all of these things. Then what will be the emergency power distribution loads? This is for a critical equipment and emergency lighting. Then whether we will be providing UPS. UPS is uninterruptible power system. So for critical building operations where we are using computers and communication networks, we have to have some UPS, because generators take few seconds to start, or some if they are to start automatically, or otherwise we have to start them manually. So this is going to be a loss of data if we are working on computer, but in case of UPS, our computers don't shut off immediately. Then again, that for HVAC, plumbing, sanitary, fire protection system, what will be the power? So basically, all of these mechanical and electrical systems, they are all interlinked. For all of these, we have to see that what will be the power source, what will be the location of the equipments installed, what will be the capacity, what will be the standby options, how we will manage if there is an emergency. So these are all interlinked. Lighting systems, we have to have some basic light source in the building. It can be incandescent, fluorescent, or HIDs. If we are providing illumination in a certain part of the building, what will be the lighting levels, what will be the color, how are we going to control it? If we are using lighting fixture in offices and other workspaces, where will they be installed? Then architectural lighting. This is the interface between architect, lighting, or electrical consultant on public or special spaces. Whether we have to introduce daylight if it's available in that area. So for that, do we have to provide fenestration around the building, or do we have to install some skylights in our roofs? Okay, then exit lighting. Exit lighting and signs are the way which help us to evacuate the building in case of any emergency, in case of fire alarm, etc. Then exterior lighting, how would be the lighting, and what would be the amount of lighting and the fixtures of lighting surrounding your building, or maybe on the exterior facade of your building. How will be they located in the landscape, and especially that where we have skyscrapers or electrical towers or airports, where we always have a warning light, red colored warning light on top of these buildings. That's to show the aircrafts that where is the danger with respect to height. In auxiliary systems, it comes telephone and telecommunication, the type, number of lines and stations, switchboard, basic, special features, if we have to provide modem, etc. Then for the public communication, we have to see that what are we using? Are we using intercom or paging system or music system? Whether we have to provide an audio video system there, like you get to see TVs in the cafes and restaurants, or maybe radio and signal distribution systems in airports. Okay, then how are we going to run those auxiliary systems? Through satellite dishes or cable? If we are using satellite dishes, what is the number? How many are we going to provide? What will be the diameter? What will be the orientation of those satellite dishes? If we are using cable, where will be the CCTV distribution systems? Where will be the CCTV located within a building, and from which room in the building they will be controlled? Similar goes for the security systems as well. CCTV monitoring, where will be detecting it, where will be the alarms installed, the controlling and interface, and where will be the security consultant sit, etc. And last, we have specialty systems. These specialty systems are specially designed for a particular type of building, like hospitals or research or computer centers. They are different for industrial, military, or defense facilities, etc. So we use these specialty systems according to the need of the building, need of the occupancy of the building.